Hello, everybody, and welcome after a long hiatus to the Alpenglow Solder Sesh. It's on Thursdays now. It's at 4 to 6. We're trying a new time and stuff. So I hope people can make it. And I'm super excited. We have Thea Flowers here of Winterbloom as our guest. Hi, Thea. And man, there is just so much to talk about. So let's just first, I would love to hear your origin story as an electronic superhero. And oh, hey, it's Liz, Blitz City DIY. Hi, how's it going? Yay! So yes, electronic superhero origin story. I would love to hear all about it. Like, how did you get into STEM? How did you get involved in programming? How did you get involved in designing electronics hardware and starting Winterbloom and the whole bang?
Well, you see, as a child, I fell into a vat of acid and TL074s, and here we are.
Here we are. Excellent. Children, do not try that at home.
No, please don't fall into acid or TL074s. Right now, they're rare, so sell those. They're like gold. But yeah, so there's like two halves of me, right? There's like this music and art half of me, and then there's this engineering side of me, and I've always been a little bit into both. As a kid, I was super curious about electronics and how they work, and I spent a lot of time at the library because there wasn't much else to do. I grew up in a very, very small town, and I read a lot of old books on electronics. I loved the illustrations in those. Like, I didn't understand anything half the time, but like, it's like reading like old patents about electronics. Just yes. Like, oh, this is so cool. But you know, I got into
like music. That Forrest Mims style sort of illustrations. Yeah.
And I got into music relatively young too. I've been playing guitar most of my life. Nice. So yeah, I got into programming, really. That's really how I got into engineering. As a teenager, I wanted to make games. I never made any games. It just didn't happen. I got distracted by other things that I wanted to do, I guess.
As we all do, as happens.
Yeah. And then, in my later teens, I was under the impression that like I was going to be a professional musician, and that was how I was going to make a living and everything. And that did not work out at all.
I hear that is a difficult thing to do.
It is, astoundingly difficult. I mean, we survived for a while, but I always had like a part-time job at a computer shop or something, right? But eventually I had to go get a real job. And I started working at a small web design firm for a bit. I didn't know what PHP was before I started that job, but they let me do it anyway. So cool.
Awesome. I know it's a database thing of some sort.
It's a web thing.
I'm very much more of a hardware person, and like the programming that I do tends to just be all embedded programming for hardware. And like the minute it's databases and web stuff, I'm just kind of like,
you know what? Your brain is probably healthier for that.
Yeah, but at the same point in time, I feel like if I had certain skills, I could put together some things a little easier. Like right now well, after we redo our website, which is, even yet another thing, we're like looking at how do we organize parts in inventory. And yeah, some database and PHP skills, I think, would be pretty handy for that.
Yeah, I am still terrible about tracking inventory. My
I'm
accountants
glad to hear that.
love that.
I'm glad to hear it's not just me.
Yeah. But yeah, so, after a while, I, moved on to a couple different companies, and then eventually started working at Google, where I worked a lot in the Python community, which I thought was really fantastic. I had a chance to do all kinds of cool things in open source there, and help organize some conferences. And
nice.
I felt like, that was a really transformative, moment for me, was being able to step into a role where I was able to spend all of my time doing open source stuff, because I'm I'm pretty crazy about open source because that's how I learned.
Yeah.
Like if it wasn't for weird people on the internet putting their software up for free, I would have never learned any of this stuff. So
Yeah.
I feel like it's important.
Yeah,
But yeah.
totally. I mean, even in just, the embedded software world, like, so
Oh my
I've learned
God.
so much from just reading other people's code on GitHub and seeing how they did a thing. And then I'm like, oh, okay, now I have a framework for implementing this myself and have some ideas about how to go about doing that. And yeah, hugely helpful, hugely helpful.
Yeah, especially like when you're working with hardware and there's like one right way to do something. You're like, how do I do this? You got to go find someone else who's done it.
Yeah.
But yeah, like so after working at Google for a while, I decided to move on.
Mhm.
And I found this weird thing where I realized that even though I've been playing music my entire life, I was always better at tinkering with instruments than playing them
Mm.
to some extent. And I started looking into synthesizers and stuff, and I was like, "Whoa, this is the thing! Like this is like the union of engineering and music that I've been looking for." And like I'd always been aware of them and known about them, but like learning about modular synthesizers with all these tiny boutique designers and all this interesting stuff going on there was really kind of inspirational for me to start exploring that space.
That's cool. So if you don't mind, talk more about modular
Yeah.
synths, because
Oh
I
yeah.
have no real knowledge about about them. I mean, I know that people use them to create these like cool looping tracks of, and I mean, they can be anything from like ethereal sounds to just crazy noise, and that it all has to do with like patch cabling everything together. And
Yeah.
that's
Yeah.
about all I know. So like,
Yeah.
what kind of like equipment do you need? And like, how do you even just get started with that?
Yeah. It's so wild. It's a niche of a niche of a niche. It's just like this tiny little part of a tiny part of a tiny part of something. But the idea is that instead of a monolithic synthesizer, like a synthesizer that does everything on its own, right?
Mhm.
Um, it's it's instead of that, you have basically the Lego version of that, where you get all these different modules that each have a specific purpose, and you connect those together to build something. And what you're building is music. It's a patch, but that patch usually generates some sort of music or some sort of sound. Like,
Mhm.
Liz from Blitz City DIY, she does some amazing sounds and music with stuff. And modular synthesizers are also used for things like generating sound effects and things like that, because there's all kinds of interesting stuff that you can do with them that you wouldn't normally be able to do with a normal synthesizer.
Like what?
Well, it kind of like opens up the the hood of the synthesizer to
Mm.
you, right? So instead of it being like this fixed function pipeline, going from one side to the other, you instead have all of these different tapping points that you can cross connect and mess around with. So it really
Cool.
gives you the chance to, flip the engine around if you want to. And where you would usually send a pitch, right, to play some note, you could
Mhm.
send instead some kind of sound to that. And when you have sound
Mm.
modulating sound, weird things happen, but it's an interesting thing that
Yeah.
happens. So
Oh, yeah, I can see how it would increase in complexity very quickly in a way that you could not easily predict. So
absolutely.
yeah, so like the joy of discovering what things do, what things do is, yeah, I can see how that's cool.
Yeah, and people don't so much, make a patch as they do discover a patch, right? Like
Yeah.
it's a constant evolving iterative thing that you explore. And that, I think that's really appealing to a lot of people who maybe don't connect with typical instruments
Mm.
because you feel like you have to play some song, and it's very metered and precise and stuff like that. But with modular, that's why you hear people making like ambient or, just kind of looping tracks, is that what you're doing is exploring the sound space instead of the space of, melody and stuff like that. You're exploring more the different sort of textures and things and letting the machine play itself while you do the rest, which is really interesting.
So one thing that I don't know for sure, but I think it might cause me some angst if I were, playing playing with modular synths and stuff. I feel like I would get to a point sometimes where I'd be like, oh, I really like this one sound or this way, like this, the last 5 minutes of what I've been playing with. I love that. But it seems like it's very ephemeral. Like it is just kind of created in the moment and then it's gone, unless you are recording, I guess, all of your output. But even then, if you're recording your output, if you wanted to try to duplicate it or just like tweak like one little parameter, that would be very, very hard to do. Like, are there people who save all their settings or who write things down, or is there a way of doing that? Like,
so there are people who write things down in something called a patch book. And, usually you're just writing down the connections between the modules. So wherever you put patch cables, and you write down the knobs, like where the knobs are at. And, some people do that. But the thing is that, as you continue to explore modular and you acquire more modules and stuff like that, you can end up with a system that, you've got over 100 cables going, and saving that patch is really not going to be an easy thing to do, right? And
well, especially if it's dependent upon a sound that you just created with the patch, right? Like,
yeah. So it is ephemeral, and that's part of the appeal to people, is that again, you're not defined into some rigidity. You have to kind of go with the flow and let yourself
I'm feeling very rigid right now.
And then, that's the thing, is like, you might stumble across a patch that sounds really cool, and you might not ever be able to recreate it. But if you try, you're going to stumble across something else, and that's going to be interesting.
Yeah. I think I would just have to like eat a lot of edibles beforehand. Just be able to chill out and zone, because otherwise I think I would get too wrapped up in like the details and like, I don't know. I like twiddling knobs and buttons when it's predictable. I like predictability in that. And so
the cool thing is that the basics are predictable. Like, you know that if you turn a knob on a filter, that it's going to make, it's going to cut off the top of the sound, right? It's going to make it like, but like, but when you have all those blocks together, the complexity starts increasing until the point where, while you understand how the basics work, how you might understand how one module is modulating another module, when you look at the whole big picture, the entire space of the patch becomes greater than the sum of its parts, right?
So. Yeah. No, it's definitely very cool. I would love to play with somebody's gear and stuff and see if it's something that I would just be like, no, I really like this, and now it's gone. Or if I would just kind of like get lost in the space and be like, ooh, what does this do? What does that do?
Yeah, it's really cool. And one thing I would recommend if people are interested in it, don't go out and buy a bunch of hardware. It's expensive.
How do you get involved?
So like there is a software modular synthesizer called VCV-Rack. And it's free, so you can download it and start playing around with a virtual modular synthesizer. Also, Propeller Head's Reason, which has been around for a long time, is also kind of in the same vein. So those things can kind of get you, sort of let you get your feet wet with it. There are also synthesizers out there, hardware synthesizers, that are semi-modular. So while they are standalone units that can produce sound and everything all by themselves, and they have it, pre-wired up for you, it has patch points where you can patch in and out to a modular synthesizer. So it's a good way to get started without buying a ton of modules, which is actually how I got started. I had an Arturia micro brute, which is semi-modular, and I was able to use a lot of its built-in things with some modules, with like just a handful of modules to start changing the sound of that semi-modular synthesizer, and then eventually, growing it and having all
Cool.
kinds of different options. So
Nice. How do you decide what to start with? Like what note or tone or noise or whatever to like feed in at the very beginning?
Most of the time I don't. One of the things that is a huge thing in modular is randomness and chaos. Is sort of starting with something that is a source of randomness, and you run that source of randomness through something that like looks at it every beat or whatever and samples it and says, okay, this is the note we're playing right now. And you can then run that through something that gives it some harmony, so it can quantize it to a particular scale. And then you have a source of randomness that is clocked per beat that then gets turned into something that is harmonious, and you could start building that sound out from there.
Okay.
Which is, I think, really neat.
Yeah, that is cool. So the randomness source, is that another module, or is
that
okay. All right. Oh yeah.
Yep.
Cool. Okay. How does what does it generally use as its random source? I mean, are we talking all the way kind of down to the hardware level where you create a random number in some way and then that is mapped to like a note or a sound or something like that and it does that? Or do you actually use something like an audio file and then it like randomly grabs something from the audio file? Or...
So the answer is yes.
Okay.
So that's one of the beautiful things about modular, is that there are options, right? You can get modules that are a source of pure electrical randomness that use like, a transistor with one leg floating or something like that to generate white noise. And then it might have some analog shapers after it, so you can turn it into pink noise or brown noise or whatever. You could have a digital module that uses a random number generator. So, pseudo-random, which is useful in some cases, right? You can have modules that don't just generate, some random signal. They can actually generate random notes within a scale all on their own, which is really useful. You have modules that are sequencers that can actually, store a note pattern, and then it can use randomness to modulate that pattern. So change certain notes within the pattern. So yeah, I think you have a lot of options, and whatever kind of noise source you're looking for, you can usually find a module that will give you that kind of noise source, nice. Randomness. Yeah.
Cool. It's funny. Liz says that like this all pairs nicely with the study of mindfulness, which I am also terrible at. So
yeah, I mean, I totally agree with her on that one. It's very much like mindfulness, and it's interesting she brings that up, because music for me is meditation. Because I can't meditate. I used to be able to. I don't know what happened. Maybe my ADHD got worse or something. But like, it's really sitting down and playing music, be it with modular or even guitar, is a meditative experience for me, because my mind can't drift. It has to be there. It has to be there playing the music. So
yeah, that's interesting. Yeah, that's why I like climbing so much, is because when I am climbing, I cannot think about anything else other than where my hands and feet are going now. And like all of the other distractions and things that my brain is like latching onto and ruminating on are just like gone for that moment.
There's time to think when you fall off the bouldering wall. Other than that, there's no time.
Yeah.
In the brief space while your body is in the air before you hit the mat.
Yeah. There's always time to think, oh shit. It turns out that's really brief. It's like, boom.
Unfortunately, gravity always gets us down.
Yes, it's not just a good idea, it is the law. So let's talk about your modules.
Yeah.
What do your modules do, and what inspires you to like make a particular module?
Yeah. Well, I mean, my first source of inspiration is necessity.
Mhm. Yep.
You know, the true mother of invention.
Yes.
For the most part, I make modules that I want to exist. And in some cases, I make modules that I think would be absurd and hilarious, and I'll get to one of those.
That's great. Yay.
And you know, it really just comes from a place of what sort of thing do I want to throw into this whole, you know, bag of tricks that we have here, this modular synthesizer. So I have a variety of modules. I have some very practical ones like Speak to Me, which is a tiny little speaker module so that you can hear what your synthesizer sounds like. There are
Seems
a lot,
useful.
yeah, there are a lot of modules out there that allow, like they're called output modules that allow you to connect to headphones or connect to, you know, an amplifier or something like that. There are not a lot of modules that have a built-in speaker. So this is great just because, you know, you don't have to have another piece of equipment. You just have that, and you can listen to your synthesizer. It also has a headphone amplifier, so you can still use it for that. So, you know, very practical ones like that. And then I have sort of modules that are inspired by things that inspired me. One of my favorite synthesizers of all time is the Juno 106. It is a legendary piece of 80s synthesizer engineering, and it's been on all kinds of songs. One of the most recognizable ones is "Sweet Dreams" by Eurythmics. Everyone kind of knows that one. That's the Juno 106.
Yep.
Yeah, I love it. So I made a module that is inspired by its oscillators. So the sound source, the voice of the Juno. I recreated. I did a huge, in-depth, like detailed research into how that works. I published a big article about it, and then I built my own module inspired by that. So it's very similar, but it has its own new quirks and additions and special things that it can do that the Juno couldn't.
Cool.
So yeah, it's inspired by, but it builds on top of what the Juno did.
Nice. And which one is that? What is that?
That one is called Castor and Pollux.
Okay, that is the Castor and Pollux. Cool. Yep. Okay.
Yep.
Nice.
And the trick is that it has two of the oscillators that the Juno has, whereas for the Juno, each voice only had one oscillator. So having two allows you to do all kinds of interesting things when they are like slightly out of tune with each other or playing different octaves and things like that.
Nice.
So all kinds of neat stuff that you can do with two. And then I have the absurd.
Yes.
I have a module called Big Honking Button that is exactly what it says on the tin. It is a big button that honks at you. And here's a little demonstration. There's the big honking button right there.
Love it.
Then this is Speak to Me right next to it right here.
Got it.
Yeah. So if I press a button, it will honk at you.
Nice.
But here's my special secret. It's actually an extremely useful module because it is more than meets the eye. It runs CircuitPython, which means that you can change the way that it works within some, you know, limitations. You can change the sample that's on it, so you can easily load different samples. So if you wanted it to make drum sounds when you press the button, which would be very useful in a modular synthesizer context,
right? Yeah,
can absolutely do that. It includes a bunch of examples and samples that you can play around with, and it's really this performance module, as we call it. It allows you to do some physical input into the modular synthesizer. And in the case of Big Honking Button, that can turn into, you know, a gate, an on or off signal, or because it has this audio output, it can be a sample or a waveform or something like that that can, you know, last as long as you need it to last. And there are interesting modules out there like that simulate string instruments. And one of the ways that they work is they start with what's called an excitation signal. It's like when you pluck a guitar string, that's an excitation, right? And in most cases, this is just white noise, right? You just use a brief burst of white noise to start your string vibrating. But if you have big honking button, you can send all kinds of different stuff into that as the excitation source. And that can lead to some very interesting sounds. So yeah, it's silly on the outside, but deep inside it is an extremely useful module. And I am honestly, frankly, deeply surprised at how many people have bought a big honking button and have kept the default program and sample on it. Because having a chaos goose in your synthesizer is great. A lot of people get 2 of them, and I'm like, all right, that's awesome.
Yeah.
Now you can,
have
use
dueling
one for
geese.
Yeah, you have dueling geese, or you can use one for practical purposes, and use the other for honking.
That's awesome. So, so arcade buttons bounce terribly. And I'm curious. Yeah, I'm curious what you did for debouncing that. Did you do hardware or software? Or
it's software. Yeah, it's software. It's the classic way of debouncing in software, where you basically have a clocked latch where it can change value, but it can't change value again until a certain amount of time has passed. So yeah, that's really it.
Cool.
Yep.
Cool. Debouncing can be like a topic. Everybody has their own favorite ways of doing it, which also can just depend upon the application and stuff. But
absolutely,
I'm always curious. I'm like, so you got an arcade button in there.
I usually stick with software debouncing unless there's some need for it. Like a reset button sometimes needs hardware debouncing, right? So
yeah.
But yeah, easier for me to solve in software.
And so, okay, so you said it runs CircuitPython, which means, well, okay, I still haven't used CircuitPython a ton yet, but we're working on learning more about it. And so one of the things that kind of recently came up is like, oh, you can't do interrupts in CircuitPython, except that there, I guess, are a few things. You can do digital I/O interrupts, I think. So I'm curious if the button is driving an interrupt, or if it's pulled.
It's pulled.
Okay. And that helps with bouncing too. Yeah,
it does. And it's one of those things where, for a lot of cases, when we're working with music and we're talking about the control side and not the audio generation side, the DSP side, so to speak. On the control side of things don't have to move very fast. We're moving at human timescales. So, it doesn't have to immediately react to your button press, right? As long as it happens within a couple of milliseconds, it's fine. Whereas when you're talking about DSP stuff and you're generating actual audio, right? You really have to do that at least 44,000 times per second. And that becomes a lot harder, right? Yeah. So
cool. So, okay, let's talk a little bit about board design and putting pretty graphics on your boards too, because your boards tend to be very, very beautiful, which I super appreciate.
Thank you. I try very hard. Yeah, so I'll show this again because it may not be entirely obvious to people, but these face plates on my modules, so everything but this module right here on the front, all of these are actually printed circuit boards. This one is, Big Honking Button has a white PCB, and you can see that it's gold plated. And then Speak to Me, this is all a black PCB with white silkscreen and gold plating. Speak to Me actually has an LED right here, and the way that that's done is that I have bare FR4 on both sides, and the LED can diffuse through that because FR4 is not entirely opaque. So that's a neat little trick that we do. So yeah, putting that artwork onto a PCB is hard.
Yeah.
And it's harder than I think it should be. And
same. Thank you.
and like there are tools out there that are amazing. Like SVG to Shenzhen is amazing for what it is. But it's tied to Inkscape, and my brain cannot use Inkscape. I love Inkscape. I'm glad it exists. I don't ever want to use it. I don't want to see it. I don't even want to think about it. It's just, it drives me nuts.
Yeah, it's not intuitive for me either. And yeah.
And so the other thing is like vector artwork. When you're creating vector artwork, you're working with programs that aren't really all that concerned about mechanical compatibility with something, right? Yeah. Like with the exception of CorelDRAW, which is awful at everything, but somehow good at mechanical things. It's
I haven't played with CorelDRAW in a long time, but yeah, it surprises me how long it's stuck around, and it's still like I still hear people using it for laser artwork.
Yeah, because it's good for like maintaining that sort of the correct dimensions as you transform things. Yeah. So SVG is a unitless format, and it is subject to floating point errors as it moves between programs. The more programs you move between, the more errors accumulate. The more you just have to scale it and rotate it and flip it around and change it, it's going to get worse and worse and worse. So I had a big challenge with these panels, kind of making sure that they would fit, because there is a specification for these racks where the panels have to be a certain height, and the mounting holes have to be at a certain spacing, right? Mm-hmm. And if that's wrong, then it sucks. Like if that mounting hole is 2 millimeters off, and I just ordered 200 of those, that's really bad.
Yeah. Or if it's like 0.5 millimeter off and it almost sort of fits, and then you just have like stripped screws, and then that's really sad too. Yeah.
So over the last year or so, I've been working on a set of tools to help me do this, to help me create these panels, maintain dimensions correctly as it translates between my art program and KiCad. And I do actually go to KiCad as an intermediary, because I want to be able to confirm all the dimensions instead of going straight from the vector source format to Gerber, which I could do.
Yeah.
But it's a little bit harder for me to verify all the things I need to verify.
Yeah.
So sending it to KiCad first gives me a lot more options and makes my life a little easier.
Definitely. I don't think I would find a tool that went straight to Gerber's super useful, because there's so much back and forth that happens in CAD that, we're looking, we need to see it in CAD, think about how it looks, be able to move that resistor around, see if that will work,
Yeah. And while my boards are not electrical at all, like they're purely for show, I do actually use the KiCad's ability to generate a step file from it, so I can check the mechanical compatibility between the board that sits underneath it and the panel. So which is really useful.
Yes. Yeah.
But, before I started working on these tools, my iteration time, like just getting a preview of this in KiCad would take hours. And, I would always be off by, 0.1 millimeter somewhere, and it would drive me absolutely, crazy. So I've been working on this set of tools called Gingerbread for a while, and they've kind of reached a state where I feel like they might be useful to other people and not just me. And what Gingerbread can do currently is take an SVG, and specifically it's kind of tailored towards SVGs that come out of Affinity Designer. It should work with Illustrator, but I haven't tried. I don't have an Illustrator subscription, so if someone wants to sponsor that for me, I will get it working with Illustrator.
There we go. You heard it here. You need some Illustrator. Pop up some SVG files.
Yeah, and what it can do is it can take that and it can pluck out your layers. So as long as you name the layers the same as KiCad layers, it can actually take that and translate it directly into KiCad, which is magical. It's really magical to see it happen. And I can actually show it if you'd like.
Yes, please do.
Yeah,
you should be able to share your screen. and then I can pop it up on the stream.
Give me just a second.
No problem. Yeah, we have some fun things coming up that Lee is noodling on some artwork for, and can't wait to try this out.
Yeah, it's been a big deal. Let's see here, share screen.
The thing that there we go. Awesome. So
yeah, the infinite repetition.
Whoa.
So this is the panel for Speak to Me, and this is in my my art program of choice, which is Affinity Designer. And I have layers for basically each layer that you would see in KiCad. So including drills and the mask layers and the silk layers and the outline. And the important thing here is that what I really, really need when I export this is for this edge cuts layer. Like when I look down here at the dimension, the width and the height, I need that to be exactly the same when I see it in KiCad.
Yep.
And the other thing is the drill layer. So for example, these holes right here, these holes are for the jacks. And if these holes are wrong, then it's not going to fit onto the board. And the same for this one right here, which is for a potentiometer. I mean, the rest of these are decorative, but these right here are very, very important. So what I can do with this is, basically export it as an SVG, and then I can come over to where it's at, and I can run Gingerbread on it, and generate. Forget how to use computers when I'm live.
It's amazing how bad my typing gets when I'm live.
Right?
Yeah.
So you'll notice that it happened really fast. It's already cached everything. So I'm going to actually kill the cache. So I'm going to do rm cache and run it again because I want you to see how fast this is.
Oh, that is so nice. Oh my God.
So that means your iteration time is minuscule.
Yeah.
So I'm going to open this up in KiCad. Here it is. And you'll notice that it not only got the dimensions right, it went ahead and added them for me here so I could verify them. Isn't that sweet? And, if I click on this through hole pad, I can, make sure that that's the right size, and it's 7.1, which is exactly what I need it to be.
Wow.
And and with that, I can go to the 3D viewer and I can look at it and I can spin it around and make sure everything looks good.
That is amazing.
Yeah, and being able to do this so quickly, to be able to iterate so fast on this sort of the graphics of everything, and to maintain mechanical compatibility is just huge. And I showed earlier that if you have something that's cached, it it runs a little faster. So if you change just one layer and re-export, it's actually only going to regenerate that one layer. So everything else is cached, so it'll run just as fast. And so it can handle, in terms of the graphics layers, pretty much anything you throw at it. For the edge cuts, as long as it's a path, it can figure it out and it will translate it correctly. You provided me some really great example files that had really, really wild outlines that I was able to find some bugs with. So that was really cool.
I'm glad. No, that was awesome. Yeah, Foxy Pride is a good one for the wacky outline. No.
And it even works with things like internal cutouts, which I think is really cool.
Yeah, that is super cool. It's so interesting because I hadn't even really thought about incorporating holes into the overall board design in a cohesive way like that. I mean, obviously you had a really it was a specific utility thing. Like the holes have to be here, and they're mounting holes. They have to be in certain spaces, in certain places, and they have to be the right size for, all these different jacks. I'm so used to that being a separate process, right? Where you go kind of through this hell of drawing your shit on a grid, and you have to have like 2 perpendicular, you know, on grid points to then measure everything else from, and then you like physically place or drag or do the move exactly tool to get it like right in the right spot, and then you lock that shit down so that you can't accidentally move it.
Yeah.
And like, and that is, I mean, it's a pain in the ass, and it doesn't it's just a pain in the ass. So I think what's so interesting is that you could actually put holes, and you could use holes and cutouts as part of like an entire board design, and not have to treat them separately. And so then you can iterate on that like way faster.
Yeah.
And that opens up even more interesting things that we could do potentially.
Yeah, for sure. Another thing that I take advantage of is when I'm designing these panels, you know, I usually design the bottom board first with just kind of a sketch of what I want the panel to look like. And then once I'm comfortable with the location of the things that are going to poke through the front panel, I use KiCad's tools to export that as a DXF. And all of my KiCad footprints have, you know, a special layer that shows the panel cut out for that part. And then I can just import that into Affinity, and I have exactly the dimensions and locations that I need to put the holes in the right spot. And then I can draw the rest of the panel.
That is super cool. Yeah, the other thing that now that I'm thinking of it, that we've struggled with is that like with the normal graphics import tools that come with KiCad, just like the bitmap converter, you can't use that to generate edge cuts.
Oh yeah.
Yeah, and then we've had issues with importing DXFs for edge cuts because for some reason it really wants to, if we have just a line that shows you your board outline, the DXF process it takes like the edges of that line and converts it into 2 lines.
Oh no.
And so you get this outline of your outline that's in KiCad, and then we're like, well, shit, that's not what we wanted. And I mean, we made that work. I think we ended up making that work on Krampus. I think we just took I think I like manually deleted all of the little segments of the inner outline, and we just took the outer outline.
Oh no.
But like, we've had so many problems with trying to get a good edge cuts because it's a different process that KiCad uses. It seems to like to get the information onto that layer versus any of your other layers, which you can just use. You know, if you're just talking about like one simple graphic, like a logo or something like that.
Yeah, that's a lot easier.
Yeah, exactly. But
when you're talking about coordinating a whole
board
of graphics, an entire board.
Yes,
that's a lot harder. And that's what this solves.
Yeah, and I mean, on Foxy Pride, we went through having to have like all of the DXFs. So even though like all the DXFs on this are all of the layers, I guess it was SVGs that we used for this, they have a different overall outline to them. So if you just take the elements of those and import them, you will get different scales between all of your different layers. And so it was like this whole process of having to import them all at the same exact like picture size that were all lined up so that they would all be the same size. And even then I think maybe Robin had to do like a little back and forth. Yeah. she's like,
I feel your pain, Robin.
So this is going to be super, super useful. I can't wait to try it out on our next board. It's going to be awesome.
Yeah, and one of the things that I'm doing now, so right now it's a command line tool, but what I want is to make it really easy for everyone to use and really accessible. And right now it's not, because it's Python, and it also uses a lot of like native libraries in Python, which You basically can't install it on Windows. I understand.
No!
I understand why. But you can, so like if you want to use it on Windows right now, you have to use Windows Subsystem for Linux, which is basically just installing it on Linux.
I would totally do that for you in this tool.
So, I mean, ideally, what I want is that nobody has to install anything. So I've been experimenting with actually moving this all to a web page, a web app, basically, that runs completely client-side, so it can run offline and stuff like that. So I'm actually taking all those native libraries that I need, and I am cross-compiling them to WebAssembly so that I can use them from JavaScript instead of Python. And I'm rebuilding basically the entire tool through web APIs. And that actually opens up a huge amount of possibilities that I'm really excited about. Like, you can create like GUI programs in Python, right? You can make Qt apps and things like that. But it's not easy, and distributing them is hard. And it's just, I don't want to do it. But with using something that runs in a browser, you have access to so many powerful tools, including literally the best way to render SVGs. So, that gives me a lot more options in terms of when you drag and drop a file onto this web app, you can reassign layers if you need to. You can apply different transformations per layer. Right now, it's just got one rule that it follows for every layer. Like if the luminosity is above this percentage, then it counts it as, a pixel. If it's not, it doesn't.
Yeah.
But with a web app, you could be able to say, no, I want this one to do, I want the threshold to be lower or higher, or I want to invert it, or I want to, instead of just having it be a solid polygon, I want to like stipple it or do some other sort of path generation with it. If you've seen StipleGen from Evil Mad Scientist for their pen plotters, we could do stuff like that.
Nice.
So it really opens up all these possibilities, and it lets you also like preview. You'll be able to preview your board before you even hit export. And what I really want is not only for it to be a version of Gingerbread that can run anywhere. I want to build on that and take advantage of the browser and create a tool that is just absurdly easy to use and powerful. that will really let you sort of, do all the things that you need to do in order to make that importable into KiCad. And I'm excited about the possibilities there.
I am too. So for anybody who is catching this and is like, oh my God, yes, I would love to send some beer money your way in order to make this a possibility, how do people do that?
Yeah, so there are two ways. There is GitHub sponsors. You can become a recurring sponsor or a one-time sponsor, whichever you would like. So you can find me on GitHub. I'm Thea Codes on GitHub. That's TheaCodes. You can also find me on Ko-fi. You can find a link to that on my website, which is thea.codes, spelled the exact same way as my GitHub username. And on Ko-fi, you can give me a one-time tip. Either way, I would absolutely love if people wanted to throw some money my way to help me, develop this. Like I mentioned, I'd love to try some things out with Illustrator, but I don't have an Illustrator license right now because I don't use any Adobe products anymore. So, paying the fee for that just to, do this one thing is a little absurd for me. But, if someone would really love to see Illustrator support, I'm happy to do that.
Cool.
Yeah. And right now I'm pretty early in the browser version of it, but I'm at the point where I've gotten all of the critical core pieces in place. Some people might have seen this on my Twitter. I showed a demo where you can drag and drop a single image and it'll immediately turn it into a KiCad footprint, which is exactly what KiCad's bitmap 2 component does already. But the fact that that's running in the browser and all of that is working there, that is the core, that is the kernel from which everything else gets built on top of. So the hard part, so to speak, the part of generating KiCad graphics from an image is done. So now it's just porting some of the other things from the Python version and then building a user interface on top of that. So, and thankfully, I have a lot of experience with web development, so I can make that happen.
Nice, man. That is all so exciting. And I have to say, like, you know, I had to use Altium professionally for quite some time, and that was, you know, that is still the program that I'm most familiar with. Although now I've been using like KiCad for like about 2 years or so, and it is like, I thought it was going to be a lot more painful transitioning from Altium to KiCad than it was. KiCad is like quite capable and quite awesome, and yeah, free is a huge bonus rather than like, you know, 7 to 10K or whatever a license is for Altium these days. But the funny thing was when I started, you know, trying to import graphics and stuff into KiCad, I was like, oh wow, this is a lot easier than it is in Altium. Like a lot easier, and this will just, you know, blow the freaking roof off of it and make it next level. Like there's nothing. I haven't been using Altium for a few years, but unless something has like come up in the past 2 years, there's just nothing like it for Altium. I will say that the one thing I could do with some graphics in Altium that I wish I could do in KiCad is it would actually, I could work with them in some sort of vector format, even in the PCB editor. So I could dynamically rescale, which is very, very helpful if you're trying to put a logo somewhere, because every board, your logo has to be a different freaking size because it doesn't, you know, it has to fit between all the things. And with KiCad, it's like a constant sort of like the back and forth.
Oh yeah,
it doesn't fit. I got to agree with it. It doesn't fit now. Oh, it could be a little bit bigger. Yeah.
I need to double check the feature list for KiCad 7, but maybe that'll make it in KiCad 7.
It'd be amazing.
But yeah, that is currently very difficult to do.
It is. It's. But you know what? Like it's a relatively minor complaint. Like it would be nice, but I can live with how it is right now, especially because it is actually possible to import graphics in a way that is actually less painful than Altium, where you had to like you had to like paste it into Microsoft Word, and it had to paste it as like a Microsoft clipboard object. Like seriously, I'm not making this shit up. I mean, you can port things as DXFs too, but like anyway, it was bad. It was bad.
Wow.
I know. It was bad. So yeah, I'm really excited about it being easier to just make cool looking boards and to have like fun designs on them, and to do that more easily.
Yeah, me too.
Super cool. So you've been making some new boards that are not synth related.
Indeed, I have.
Yeah, you want to talk about that project? Because I know that a lot of people are very, very interested in these types of machines.
Yeah, because I obviously cannot stay on topic or one project at a time. I have multiple projects going completely unrelated. So
Fair.
yeah, I've been working with this machine right here, which is called the Lumen PNP. It is a pick and place machine, and it is open source, which is really cool. And I like it. It's neat. It for those of you who don't know what a pick and place machine is, it will pick up all the tiny little components, surface mount components for you, and put them on the board for you. So it's a little robot that toils away doing all the terrible placing of components that, you know, if you've ever made more than 10 of something, you understand why these machines exist.
It takes the place of you and a pair of tweezers and a microscope.
yeah, and a lot of time and bad knees. Yeah, so you know, I've been working on making mods for this. There's quite a few that I've already done. Like I put linear rails on it. If you know, people with experience with 3D printers know, like the difference between like V rollers and linear rails is like night and day. So yeah, it has linear rails on it now, where it previously had V rollers, so I can go very fast. And that's very charming. I also decided that I would create new control boards for it, because it has this head on it that has a bunch of stuff on it. So like the tool head that you would like typically see on a 3D printer that just has like the extruder basically and the heating block. Or sometimes the extruder's not even there, the extruder's somewhere else. It's just got the heating block, right?
Yeah.
On a pick and place machine, oh no, there's a bunch of stuff on there. So
There's
it's
a
got
vacuum thing.
Yeah, so it's got a Z-axis that goes up and down, so you can pick
Yep.
things up and put them down. That Z-axis has a vacuum powered pickup tool. So you got to run a vacuum line through it. That picking tool also is in a has a stepper motor, so it can rotate. So that
Yes.
So that when the machine picks up a component,
orientation.
Yeah, it can go take it over a camera. The camera can look at it and figure out how much it needs to rotate, and then the head can rotate it. So it's got, a motor for that. So you have a motor for the Z-axis. You have a motor for each of the heads. There's 2 heads on it, so it's got at least 3 motors. Then you need to work. It also has the top camera on it. So the top camera can look down to help figure out where boards are and where it should place components. And it's got LEDs for those that it needs to control. So the way the Lumen works right now is that it has one control board, and then it runs what's called an umbilical to the tool head. And that umbilical has a lot of wires in it, for each of the things that need to happen on that board.
Probably does weird things to the dynamics as it's moving because it's stiff, right?
It doesn't mess with the dynamics too much, but it is annoying to me. So what I decided to do was I made a board that goes on the head itself. So this little boy right here is called Jellyfish. There's a little jellyfish on the back of it. And what it does is it has all the stuff that it needs to control the head. And so it's got, a RP2040 on it. It's got 3 motor controllers, one for each of those motors that need to be controlled. It's got connections down.
What controller chip are you using out of curiosity? And was it hard to find right now?
It's the TMC 2209, and right now it's actually not too hard to find.
Cool.
I was able to get them no problem. So these are the same motor drivers that are on the Prusa Mini.
Okay, cool.
Yep. So it has connections down here at the bottom to control the LEDs and the top camera. But the really interesting bit is that there is a small footprint over here, and I'm waiting for the actual component to arrive. And it says not Ethernet at the bottom of it.
Yeah.
And
but it looks Ethernet, but it's not Ethernet.
The reason it says not Ethernet is because this board right here is actually what gets sent to Jellyfish. So this goes on the bottom of the machine. This goes on the head. In between them is a Cat6 cable. On that Cat6 cable is not Ethernet, my good friend. It is cursed. It is 24-volt power and 2 USB differential pairs.
Nice.
The thing about USB and differential pairs is that twisted pair is twisted pair. It's all the same.
And you got a lot of it in an Ethernet cable, so why not use it?
Exactly.
Makes sense to me. I like it.
So it turns out Cat6 is more than capable of carrying USB high speed. So so I'm sending 24 volts of power and for the motors, and the USB for the top camera and the USB for the controller on this board itself through this. So that's why it has ignore the third one, but that's why it has 2 USB ports on one side and an Ethernet port on the other.
On the other side. I love it.
So as cursed as this is actually kind of common in industrial situations. Lots of industrial things use Cat6 or Cat5e to talk to each other, like RS485 can run over Cat. And it's totally not uncommon for this to be used for different things. And
there's something to be said to not have to make a custom connector system. Like that is a really difficult and expensive proposition. And So why not just use the nearest thing that has all of the characteristics that you want and is being pumped out by the millions?
Exactly.
Yeah.
And having them be so well spec'd like Cat 6 and Cat 7, like knowing exactly what you're getting in that cable is incredible. Yeah. Actually, I've even seen some like measurement instruments, test instruments use HDMI to connect to each other. And
That's
it's
kind
the
of
same
cool.
principle. It's
Yeah.
a bunch of high-speed pairs, but I'm like,
Yeah.
whoa. That seems really wild. Let's not use HDMI, my friend. Yeah, so
Cool.
there's another control board. So this is the control board for the rest of the machine.
Mhm.
And it's very similar to Jellyfish. It just has,
Continuing the C names. I like it.
it's Starfish, which is great. So Starfish is almost the same as Jellyfish. It has a RP2040 again. It has 3 motor controllers, TNC 2209s, so it runs the same firmware. These 3 motors control the x-axis and the y-axis. The y-axis has 2 motors. And it also has a bunch of MOSFETs on the side. Oh, it has 2 MOSFETs for turning on and off the 2 vacuum pumps.
Okay.
And it also has 2 smart solenoid drivers to control the valves that open and close the vacuum.
Cool.
So that's a very useful thing to have. At the top here are footprints for vacuum sensors. I just got the vacuum sensors in, so I haven't had a chance to actually solder them on the board. But these 2 footprints up here are for vacuum sensors. There are 2 quick connectors on the side if I want to add some expansions. There's a header here for RS-485 for talking to powered feeders. Right now, my machine has passive feeders. So as it picks all the components off a strip of tape, I have to manually feed it more tape. But in the future, I will have powered feeders that will automatically feed it more and more tape, which is great. Yeah, so it's got, you know, a little bit more I/O than what, you know, Jellyfish has. It also doesn't have the cursed Ethernet. But yeah, these boards are very similar. Like I designed Jellyfish first and then copied the KiCad file and then added the peripherals that I needed for this one. And, you know, did another set of routing.
And is that one also an RP2040 board?
Yep.
Cool.
Yep. And I'm running my own firmware for this because I don't know. I guess God has cursed me for my hubris, and now my work is never done. So
it's always good to have a project. Or 10.
Yeah.
Of varying degrees of complexity.
Yeah. So I'm basically writing 3D printer firmware from scratch. It's G-code powered. So yeah, that's what's going on here.
Cool. So yeah, I was just thinking like all of those interfaces, are you using up pretty much all of the pins on the RP2040?
Yes. This board uses every single pin on the RP2040.
Nice.
So I maxed it out. Some of them like aren't like in use technically. Like there's like an input header here and like an aux output header that I'm not using for anything right now, but I might use it for in the future. But yeah, I use so many pins that I actually had to get a I2C multiplexer for this because it has the 2 vacuum sensors and also a quick connection. And I just didn't have enough pins on the RP2040 for that.
Yeah.
And I needed one anyway because the vacuum sensors have the same I2C address. You can't change it. So, so I lucked out on that one because I ended up needing it anyway. But yeah, every single pin on the RP2040. And that actually comes to like my one big criticism of the RP2040, except for not having built-in flash, is that it doesn't have enough pins.
I know.
Where's my pins? Raspberry Pi? Give me more pins.
Yeah. It's funny, like, yeah, even I was working with it on a project. Actually, it's kind of funny. So Alicia White's embedded programming class you must be like channeling each other, because she has for her cohorts, she had the red jellies and then the orange stars, which were starfishes, and I think the third one is seahorses. So you might have to have your next board be seahorse themed. I'm just saying.
If I have to put together another board for this thing, yeah, I will. Yeah. I will name it Seahorse.
Excellent.
In her honor.
Excellent. But yeah, I was working with the RP2040 for the first time for my project on that, and it was surprising to me how fast I ran out of pins. And I think it's a little well, they give you you can do so much. You can have so many different interfaces mapped out that it just makes you expand all of your capabilities immediately and then run out of pins.
Yep.
It's like, oh wait, I can have this. Well, I totally want that, and then you're like, ah, shit. Maybe I have to descope now because I'm out of pins. Damn it.
Yeah, or get a port expander.
Yeah,
so
get a port expander. Yeah, I was actually looking
which will cost more than the Raspberry Pi.
Exactly. I was looking at. I was wanting to drive some analog RGB LEDs with it, like four of them, and have them all be different colors, and which of course requires like 12 pins. And so, yeah, I was actually looking at potentially doing like an I2C to RGB. Yeah, and there is a chip. There's a chip for that, which is kind of amazing. But yeah, it was of course more expensive than
You could definitely do that with like a PWM controller. Although I guess you'd only get 16 channels out of something like that. Yeah, there might be a 24 channel one. I don't know. But yeah, that sounds awesome. Yeah, I do like the Raspberry Pi. I do like the 2040. I wish it had Flash built in, so it doesn't take the cake as my favorite chip, but it's been great to work with. This is the first time I've worked with it, and I've enjoyed it. It's also been super easy to lay out. They have great documentation. The SDK is great.
Yeah.
So I'm impressed. I would love to see Raspberry Pi do more things.
What kind of toolchain are you using to develop on it? Are you doing Unix-based, or sorry, like Linux-based stuff, or?
So I'm using the Pico SDK. So yeah, it's their C-based SDK. So pretty much bare metal.
Are you running it? I guess are you running it on like Windows or Mac or?
Oh, on Mac. Yeah, I've been doing most everything on Mac. Yeah.
Yeah, it was a little hard to get the Windows toolchain up and running.
Yeah,
Windows. I know. I was like,
the ARM compiler is hard to set up on Windows, so I'm not surprised. Yeah, that's the funny thing about Windows and embedded. It's like the big players. It's like you have to use Windows. You have to install our 400 megabyte IDE. You can only use that to program your chip. Yeah, and then it's like Raspberry Pi is like, nah, this is just some. We just threw together the GCC compiler and some tools. Have fun.
Cool. Well, that is all. Yeah, that's cool. I'm excited to see updates on that project as it comes along. But you know that the next thing that you're going to have to build after you get that all sussed out is the optical inspection machine for for post reflow. Sorry, not that you need more projects. I'm just saying.
Please, I'm begging you.
Oh, awesome. So yes. So Python. Let's talk more about that. So you've done a whole bunch in Python, and I'm curious if you have any tips for people who are looking to learn either Python or CircuitPython, either one of them, and kind of don't necessarily know where to start or don't know what the best way of like just kind of diving in is. I will say that my way of diving in is like, oh, hey, I really need a script that like takes all of these different CSVs that different websites spit out and puts them in the format that my shipping software wants so that I can just like upload it and just be done with it. So that was why I learned like a little bit of Python and how to handle files and how to do like some of the I forget which library it was because it was a while ago that I wrote it and haven't touched it in a while. But I was impressed with how easy it was to manipulate words and have Python open a CSV file and automatically assign headers and things for you, so you could refer to things in a very natural feeling way.
Yeah,
But
definitely.
I definitely am not well rounded in Python, so it's kind of like, okay, well, what else can I do that would that would allow me to upskill in Python?
So I think the way that you approached it is actually a great way of approaching it. Like approaching Python as a language that can help you deal with something that you might do manually is a great way to learn it. And there's actually a really fantastic book by a friend of mine called Automate the Boring Stuff with Python.
That is totally the book that I used in order to help, which Deborah Ansell loaned me. Thank you,
That's great.
Deborah,
Yeah.
for the book.
So the book's by Al Swigart. It's available at No Starch Press and Amazon, of course. But it is so great because it's practical. Like
yes,
I feel like a lot of people have trouble wrapping their heads around programming in general, just because when you start doing it, you're learning syntax and you don't really know why. Like, what am I doing with this, right? Like, where is this going? Why is this useful?
Yeah.
But with Automate the Boring Stuff and his other books, which are, he has one like Invent Games with Python, which is great if you're more visually oriented. But it's just so practical because it's going to tell you how to solve actual problems. And that's how you're going to have stuff stick. Because, and that's the thing is like, I recently started learning Zig, which is another programming language. And I've been reading about it for a while. I looked over the documentation. I, played around with the syntax a little bit, but it wasn't ever going to stick in my brain until I had a project for it. And then I found a project for it, and now I'm actually starting to learn it and become proficient in it, right? So yeah, my recommendation is get Al's book and find something that you can solve in your life with Python. And there's almost certainly something. Yeah, like it's a practical language above all else, right?
Yeah.
There's many incredible things that you can do with it, from machine learning to, writing video games. But, it's really practical at the end of the day because it's easy to pick up. It's easy to put down. It's, it's there. And it has libraries that help it talk to pretty much everything. So.
Yeah. And yeah, that's interesting too. How do you find out what libraries exist and could potentially help you? So I think I generally learn about libraries by like looking at other people's code, I guess, and like looking up like just general web searching, like how do you do this thing? Or
yeah, I mean that's a great way. The Python package index itself, so pypi.org, has a search functionality, so you can throw a query in there and see what comes up. Cool. If you have like a specific task in mind that you think is probably something that a lot of people have dealt with, you can check out resources like Real Python, where they have some more opinionated things about, here's a couple of different libraries that you could use for this, but here's when you would use them in specific circumstances.
Yes, that is super helpful.
Which is useful, which is very useful because there are a lot of cases where there are multiple Python libraries to accomplish a specific task. And it might not be immediately obvious to you which one you might want to use for your specific situation.
Yeah. So, cool. Yeah. So basically you're telling me that I need to make my own parts database inventory system with Python, and that's how I will learn more about Python.
You will learn something. Don't know if you'll like what you learn, but you'll learn something.
I'll be sure to tweet out all my feelings about it. It'll help.
I would love that. But also, if you decide to do that and you run into any trouble, feel free to reach out.
Well, thank you. I super appreciate that. That's awesome. Cool.
Yeah, what's the point of knowing all this stuff if I'm not helping other people?
Actually, oh yeah. That totally reminds me of something that I've like definitely dropped the ball on, but would like to coordinate with you at some point in time. I don't know. It might not even be very useful anymore if like people can get a wide variety of SAMD chips now. But I ended up basically making a board for Arduino for the G17. Wait, SAM-D21
G17.
G17. Yeah. And when G18s were unobtainium. And so, and yeah, it would be great to get a second set of eyes on that. I have to like pull out some customer specific stuff out of it and put it in a more generic format. But yeah, it would be great to get your eyes on that, because I know that you have experience in that as well.
Yep. Yep. I am a walking SAM-D21 data sheet, unfortunately. Or fortunately, I don't know. I don't know. Sponsor me, Microchip.
Right? Yeah. Right? Want more of your chips available for the Arduino interface? Oh, yeah. Cool. Man. I don't know. Let's talk about your amazing documentation. That is beautiful and thorough. Do you have any, how do you approach documentation, and do you have any guidelines for people on writing their own documentation for their boards or products or code?
Yeah, absolutely. And I will have to make this relatively quick because I'm running out of time.
Sure.
But I'm going to turn into a pumpkin.
Yeah.
Yeah. So I generally approach documentation in somewhat different ways depending on the audience. But when I think about writing documentation, like for my products and for tools and things like that I want people to use, like software tools, like Gingerbread, for example, although I haven't really written documentation for that yet, is like, I want the documentation itself to be something that people like to have, right?
Yeah.
And it sounds like so absurd because, like, these days, what's the first thing you do when you open a new gadget? You immediately throw away whatever manual is with it, right? I mean,
no,
there's not
I put them in a drawer. I put them in a drawer. There's the manuals drawer.
There's not any useful information in there anyway, so you're just gonna throw it away, right? So, I take a lot of inspiration from old video game manuals because, when I grew up, because I'm a dinosaur now, video games had instruction manuals with them, and there was a lot in there. It was like a little book. It was like a little comic book,
and the maps, the
drawings, there was so much to them. And I loved, like, as a kid, like even before I would play the game, like, on the car ride home from getting a new game, and open it up, start reading the little manual. Like, those are very inspiring to me because they are themselves something that you'd like to have, right? Like, there's a reason people collect physical games. It's because there's all this cool stuff with it. It's like album artwork for vinyl records, right? Like, you get this big, beautiful book sometimes that has like incredible photos of the bands and lyrics and stuff like that. And sometimes even like a small story or something like that behind the album. And that's kind of like what I aim for, but with technical documentation. And it's hard to get there. But, if you look at things like my article on the Juno oscillator, or the manuals for my products, like even a product as simple as our power supply, it's called Micronova, or a product like Speak to Me, which is literally just a speaker. You plug it in, it makes noise. Like, even those, I try to make it where it's something like, when you open the page, you're like, I'm happy to be looking at this. Like, and the structure of the actual information and how I present it is very much the way that you would present instructions for how to play a video game to someone who hasn't played a video game, right? It's like, you open up the Mario manual, it's like, press A to jump, and you're like, oh, okay. What next, right? Left and right to move. You're like, okay, cool. It's the same thing with my products, where I'm like, okay, like, you can plug in one thing here and it'll start playing some sound. If you plug in another thing, it makes it stereo. If you plug in some headphones, you can listen to it. And I include illustrations and things like that, where it's like, that's sort of inspiring to people, is to be able to kind of see visually and both, read about what they should be doing. And in the case of some of my more technical documentation that covers really complex topics. Like in the Juno documentation, I break down every element of the circuit that powers the oscillator. So literally, like, why these two capacitors are here, like, why their values are what they are. Like, it's stuff that's just never explained to people in most documentation. And the way that I explain it is I let you play with the values. I give you, a slider and an interactive thing that shows you what happens as you change the parameters, like, of this circuit, right? If you, lower the capacitance, what happens to this filter? If you increase the resistance, what happens, right? As you change the voltage going in, what happens? And all of this is interactive and like visual and illustrative. And it's something that even if you're reading it for the first time and you're not fully understanding it, you get a sense for what's going on. And it's a joy to actually interact with. So it'll get you to come back. It'll get you to actually sit with the material and understand it. And that's like really what my brain thinks about when I think about documentation, is giving people practical ways of understanding what's happening and what's going on, and presenting it with a level of attention and beauty and, a little bit of flair, like a video game manual that you want to actually read it. So because the number one rule when it comes to technical documentation is that nobody reads. So,
I've read a lot of the RP2040 SDK and that SAMD datasheet, right?
Yeah, and the thing is like, when it comes to writing reference documentation instead of like, more guided documentation, I have a completely different approach. And, I think a big thing is knowing your audience and knowing what you want your audience to accomplish with your documentation. Because someone who is, trying to figure out how to change the I2C speed doesn't really care about a guided tutorial on how to configure I2C from the start, right? They already got that. They just want to change something. So that's a reference, and you need to make that a completely different experience for them.
That's a good point.
Yeah, so I would say, if you're going to write documentation, first thing you should do is just write something. Most people don't write anything. So write something. The next thing is get other people to look at it, because other people will tell you if it sucks, and you can use that to improve. The third thing is that if you really want it to be amazing, hire a technical writer or a technical editor, because they can really help you, and they're not that expensive. And when it comes to making sure your product is successful or your open source project, really takes off, they can make the difference. know. So
cool. Well, it has been awesome having you on.
It has been awesome being here. Thanks for having me on.
Oh, no problem. Like, thanks so much. It's been great to finally like meet you face to face after so much twittering and things like that. And and to get to nerd out with you for a little bit. That's great. Hope to meet you in person someday. That would be awesome.
One day. I will take corporeal form and haunt the living once again.
I like it. Cool. Well, awesome. Thank you so much for coming on. And thank you, everybody in the comments. Thank you very much, Liz.
Yeah, thank you, Liz.
Thank you, Frequency Heaven. I don't know who you are, but I appreciate it.
I know who you are, Frequency Heaven.
I like the username. It's good.
It's a good one.
Cool. Awesome. Well, until next week, when we're actually going to have Anne Barella on, and I'm very excited about that.
Awesome.
We're going to talk space and more Python and stuff with her. It'll be good.
Nice.
Cool.
Nice.
Yeah. Awesome. All right. See you. Bye. Yes, end.